Hi. So today we're gonna look at doing some kind of Vellum-ish sim without Vellum. So it's not a sim actually. But the idea is to do something like this, like grass, fur, whatever, blowing in the wind, and not using simulation tools at all, but rather doing it with noise and shops to smooth out the results. So basically, what we're going to do is use some hair tools and some noises and some chops. So let's get started. Just going to save my project. Just going to save it here, it's fine. To well shops or something. So what we want to do is we want to have a grid with some kind of reasonable resolution that we then use to drive the noise and scatter points on. So I'm just going to do a 200 by 200 grid. It can be 10 by 10. I think that's fine. So what we want to do on this is we're going to scatter from it. And let's say that we just want to do 1,000 points. That's fine to start off with. And then we want to do a noise. So we're going to do a point swap for generating noise. And the noise is what will drive both the normal of the points as well as the bend of the points. So what we can do is we can do an AA flow noise. That will be our main noise. So we have to do position to position and we promote the frequency and the offset. So then we want the flow to go for somewhere. So we take time and we multiply constant to get it slower and we bring it down to 0.2 or something like that. Let's plug it into the flow, and then we choose a 3D noise here, and we can plug it into the normal in order to see what we have. So it's kind of hard to tell here, but we see that we have something that flows like this. And that's quite good. We can go back and look a little bit on the frequency and stuff. So basically we want this to be a higher frequency in X compared to the rest of the channels. So we just bring this down to 0.2, and then we bring this down to 0.06 or something. So we have a lot higher. And it's kind of repetitive now, but that's fine. Won't show in the end. We could change the Y, but since nothing happens there, so it doesn't really matter. So then we can offset it in X. So we can do $T divided by 5 maybe. And then we have an offset on it, so it moves as well, which is good. Cool. Then we step back in because what we want is also another noise that's a little bit more, a little bit faster, and yeah, we just want another noise as well, and that doesn't really need to be offset by flow. So we just do an AA noise. And we make this also a 3D noise. Or no, what we want is, sorry, I'm saying the wrong thing. We want this as a 1D noise. We just want this to be like how much noise we apply to the different areas. Sorry, I got a little confused there. So what we can do is just do an AA noise. We promote frequency and offset. And what we can do is we just fit it, because an AA noise, as you know, goes to negative to positive, and it goes, the documentation says it goes up to and down to plus minus 0.5, but I find it rather be around 0.3. If we check this to color, you will see that we have some dark spots here, and we don't really have some brights, but that's fine. We have some kind of thing to it. So we can multiply these two. And then we could just plug that in instead. So now we will have quite short normals on some places. But what we have is kind of some things that actually gives it a little bit offset. And what we're going to do is we're going to check the length of these normals and also save that as an attribute. So it's going to unplug it from the normal, and we're going to pretty much, we could export this as it is, but what I want to do as well is I want to add a constant to the Z-axis. So I also want to do that with the noise. So I can take another noise. And this noise should probably, I don't know if it should be offset, but I'm just gonna promote the parameters anyway. And I can have it as a 1D noise. And I'm just gonna fit range that as well. So I'm just gonna do pretty much the same thing, minus 0.3, plus 0.3. And then I want this negative, so I'm gonna bring this down to 0.3. I'm gonna convert it to a vector, so I have to float to vector. And I'm gonna plug it into, let me see here. Is it? It is, let me see here. So it is X that we're offsetting. Yes, so it's X we're gonna do it for. So that's good. So we have this, and we can just add this to this other one to get a constant direction as well to it. If we look at it now in the normals, we see that we have a little bit of this kind of, it adds to the X. So if we remove it, we see that. Yeah, so we give it like a base direction kind of thing. So what we can do now is we could export this. I don't know if it's too strong though, maybe. But what we can do is we export this, find export as bend direction. And we also take the length of this and export that as bend amount. Bend amount, let's call it like that, bend amount. Oh, sorry, not colon. So there we go, we have those two. And since we have this normal thing, now it's straighter normals, that's not what we want. We would rather like to take the normals and mix this with what we get here. So we have something that's quite turning upwards, but not completely. So we can do like this. And the thing is, as you see, we have a mix here, that's 0.5, but it still looks very straight up. That's because this one is not normalized, so it's very weak. So we can bring up the bias a little bit. If we bring the bias completely, it will just have those, but we can do like that. And then we could maybe bring it up a little bit more, sorry. Something like that, maybe. And then we can normalize it. So we have it, because these normals we want normalized. So there we have something that's bending, but quite straight anyway. That's good. So what we can do now is we could attribute transfer this to the scatter. And you might wonder why I do this as an attribute transfer rather than just scattering on these. And I'm going to show you that. So attribute transfer works perfectly. But if we were to do like this instead of take a scatter and point this in, you will see that we get a little bit of jittering because the normals affect the scatter. So we can't do that. That's why we do an attribute transfer instead. Cool. So now we have our scattered points and we're ready to copy our hair/grass onto this. So let's do that. Let's bring it on a line. And since we do a copy to points and we use the normals, we need to do this line in the Z direction. We can then do a resample just to set the amount of points. Set that to 8. And we also output the curve view because we're lazy and don't want to do it in vex. So when we have this, we're just going to change the point numbers and we have 0 here. That's good. The 0 is the root. So we can just do a wrangle. And this is just good practice, I think, to have the root separated. So I just say group 0, which is 0.0. And I just do I at root. Because you never know when you need this. And what I sometimes do is I actually do also a group for that. So I have both a group and an integer for it. And might not be needed, but I think it's good to have. Then I do another wrangle, and I'm just going to set the width for this. So what I'm going to do is I'm just going to say f at width equals to a ramp over curve view, because we have curve view now, as you know. Just going to do width, and I'm just going to do at curve view. And we also need an amount for this. I'm going to do a float channel for that as well, which I call amount. So when we have this, we can set the width, and we're going to do B-spline. We're going to do B-spline. We're going to bring this up, and we're going to do a little bit smaller, and then we're going to like do a little bit of tapering to that. Something like that. That's a grass straw. We can all see that. And then the amount maybe should be 0.2 right now, because we're quite Well, you can't see this right now. What you need to do in order to see it is that you need to go to the MISC and you go to Shade Open Curves in Viewport, and then you see how the grass looks. If we move this, we see it more clearly. So that's a grass draw. I think that's good enough. Cool. So what we can do now is we can just copy the points here. So we bring in our grass draw and we bring in our points, and here we go. We have these. I'm just going to remove so we don't see that and that. And we see now we have some kind of movement to them. And this is, I mean, this is not good, but I guess it's okay. We can see here that we have some kind of wind moving, coming. I wonder if it should, maybe the flow is too much. I think the flow kind of fucks it up. Just going to take down the flow to 0.1 instead. See if we get a little bit more clear movement now. I wonder how it looks if we offset in that another direction, because it kind of looks, let's see if we do -t instead here. Yeah, I think that's better. It feels more natural. Yeah, I think so. It feels like it moves the right way. Otherwise, it looked kind of offset. If we want to fuck it up more, we can, of course, do these kind of things as well. But we also want to offset the other noise that says how much we apply. So we do $t here, and we divide that by 10 maybe. And we do that minus as well. So now we have a little bit offset to that one. We could, of course, look at the frequency here. Could bring them down maybe. I think we should bring this down as well to maybe something similar, like 0.2, and then maybe 0.1 maybe, I don't know. It's a bit jagged and stuff now, but we're gonna fix that. And it's, of course, it's very few grass draws. So yeah, I think this is nice, good enough for now. So what we want to do now is just going to give them some kind of attributes for hair, and that's needed for some things, like some hair tools need to know skin prim and skin prim UV, etc. But it's quite easy to access. We're just going to do an attribute wrangle, run it over primitives, and what we want to do here is we just want to define some things. We want to define skin prim UV, and we're going to do it's a V, of course, it's a vector. And then we're going to do I at skin prim, which is an integer. It just says what prim it is. And this one says like a, it's not UV map as a UV map, but rather a local UV map for each primitive, which says where on the primitive are we, with going from 0 to 1, lower left, I don't know, it's lower left corner to upper right, I don't know. But it just says where on the prim we are. And we also need an ID, so we're going to say I at ID is equal to I at primnum. That's good. And then we can use a very handy function, which is XYZ, say, and I write something else, XYZ distance, which returns both the skin prim and skin prim UV, or it returns the primitive it's found and the UV on the primitive. So what we can do then is look at the first input, which we have nothing in, but we're going to have our skin, and we look at the position and we return skin prim, and we return skin prim UV. So in that very simple setup, we get the skin prim and the skin prim UV, as we can see here on the spreadsheet. Do we? No, we have nothing in yet, sorry. So we're just going to bring in this one, and we see here we have skin prim and skin prim UV. So it just references what primitive we have and where on that primitive we are, which is something that some of the hair tools really need. So after that, we could do a guided form, a bend, a guide process bend, sorry. And what it wants is our guides, which we now have, and our skin, so to speak. So, and this one, we want to bend it, but we do not just want to bend it in root direction, but we want to use a direction skin attribute, which is our bend here. So what we have now is this kind of bend. No, it doesn't work. Isn't the bend here? Oh, sorry, wrong input. Here we go. Now we have it. So if we increase the angle here, we'll see that it bends with our bender. Quite a lot and quite things going on, but it's getting there. We're getting better. It's getting better. So we both have the normal and we have the bend thing. So that's good. And then we can also take a guide attribute for the angle. And we call that, let me see here, bend amount. So we can just copy bend amount, go down here, and then we do bend amount. So now we see we get a little bit less, and it's a little bit jagged, but we'll fix that. So we maybe can take up just to 90 or something. And we're also going to add a random angle to this. So I'm going to add 15 to a random angle. So this is good, I think. It's quite jagged as we see, but we will fix that one, like I said. And I also don't really like the linear kind of bend here. So what I want to do is I want to mix this with the unbent. So here we have the unbent stuff, which is just straight. And we're just going to do a point swap where we look at both of these. So we're going to take our guides and we're going to take our bender. And before we do that, we're going to do an attribute promote, where we're actually going to promote our ID from primitive to point, but we're not going to delete original, just to have an ID here. We could also do an XYZ distance, look at the primitive, read the ID of that primitive, etc. But this seems a little bit faster. So if we do a bind and we bind in ID, we can see that we have a random, we can generate a random value for each of these. You see some are white and some are black, which is exactly what we want. So that's good. So we want to use that to give it a little bit of randomness. And we also want to just blend between these two. So in order to blend between these two, we just do a point attribute here from the second input, which is our, so to speak, rest. And we just want to look at the position and we want to look at the current point number. And what we can do then is we just do a mix here. We mix our position with this. And if we plug this into position, we'll see that we have a blend between deformed and not deformed, which is good. But the thing is I want to do is I want to have it bent more upwards than we have from what we're given. So in order to do that, we can bind in our curve view, which gives us a value of, which is white on top and black on the bottom. So we can pretty much use this, but in order to get a little bit more control, we put it into a ramp. We call this curve U ramp or something like that. And it's a spline ramp. We just plug it into bias. And now we can say that on the top, we go down, and on the bottom, we just raise this a little. So what we can get now is a more non-linear blend. As you can see, we can control this a little bit, how it actually bends. And I think this is better. It's not linear in the way you get from the bend. So that's good. The thing is then we can also do another mix where we take this value and we take our non-deformed value again, which is this. And then we can do the bias from the random. And if we plug this in, we will see that some will bend and some will not bend. And this is probably too hard, so we're just going to do a ramp here as well. So we do a spline ramp here as well. And what we want here is we want it to apply to some degree to all of them, but not as much, just to get a little bit of random. So that's cool. Now we have a bit of random to it, and we have this thing generating some kind of thing here. We could, of course, just look how it looks with like 10,000 instead, because it's just a matter of clicking, and then we see we have something that's quite a lot more interesting. And we see a wind moving towards it, etc. Now it's just one direction, and but it still looks quite decent, I think. Maybe it's too fat now, so we can bring it down to 0.1 just to see it a little bit better. What you could do as well here is that you actually go in and let me see, where do we have it? We have the anti-aliasing. You can bring that up to 32 if you want to, and that removes some of the more annoying noises. It looks a bit smoother. It's still you kind of need anti-aliasing here. Could also see how it looks with a black background. Might be easier to see, I think. But still, yeah, there's some jittering there. Yeah, cool. Well, we have this. And the cool thing with this is that we can actually use other guide processors here as well. So we could do something really crazy, like, let's say, we could add like a hair clump and bring in our skin here. Just take the skin from up here. And what we'll get here is when we increase the clump size, you will see we actually have this, which is quite cool. So it's quite simple to generate this kind of more weird stuff. And you could, of course, tightness, you could take a little bit. I mean, this is not necessarily a really bad idea. You could also add stray amount quite a lot, and then you have a little bit of clumping, which I think could look cool, actually. I don't know. I could also take down the blend just to give it a little bit of that kind of things. I don't know. It gives a little bit of structure that might be cool. It's not what I intended to do, but yeah. Then you can use things like set length as well to get it randomized. Now it's just set here, but instead of doing set, we could do multiply. We can randomize, and we can have like 0.7 to 1 or something. So we have different length of them. And we could, of course, do other things, like we could freeze it as well if we want to. I mean, this is up to you. I mean, I don't know, depending on doing grass or hair or stuff. But if we're doing freeze, I think rather do it random than just adding it plainly. So we have some freeze, some not. Might be too much, and frequency might be a bit too high, so we could bring it down to maybe, I don't know, something like that. Could be cool. Well, my point here is we have all the groom tools available to us because we have set it up as here, kind of. So that's cool. But what we want to do then is we want to, like, the main purpose of this is to do this kind of filtering of this as well. So what we do then is put on a null, and what we want to do is just call this something like auto shops or something. Save, because shops can be a bit buggy. So we do a shop network, we do a channel, we plug the shop network in here, we do animated, we go into the shop geometry, put down, we do a sops auto shops, that is, where it shows animated. It's gonna lock here. Doesn't matter, it should see what we want to see, but we go down to channel and it processes it. And the good thing with that is then we can start adding filters in real time. Now I have a little bit more points, so it takes a little bit longer, but it should be quite fast, even though with this. What I want to do actually is when I abort this, go back up here and just change this to 100 frames to get it faster, because the shops, as you know, works like in a temporal way, so it kind of checks the entire timeline, or it checks what you say here. We have useful animation range. We could set that to something else, of course. But if we do that, we have the ability to start by just filtering this. And what the filter does is it applies kind of like a blur, but a temporal blur. So we get something a lot smoother here, as you can see. might be a bit too much. I think we should bring this down to maybe 0.5 or something. So we have something like that. That's cool. It's not that much wind right now. Maybe we should add that as well to make it a little bit cooler. I think we should actually. I think this is a bit too weak. Let's gonna go up and go here and see if we can do a little bit more of the, sorry, up here. Do a little bit more on the main noise. So bring up the amplitude to 1.5 and see how that looks. And I'm also gonna do the normal thing a little bit more. Let's see, we do the bias here. We're gonna bring it up a little bit more so we get a little bit downward movement. I think that's cooler. A little bit more exaggerated. So let's go down to the channel again. It will have to recook. I think this is cool. We see a little bit more of those kind of movements. And the cool thing with this is, I mean, you could so easily just add stuff to this point warp. You could take geometry and add it in and take the normals from that to get like kind of spacecraft kind of effect, blowing it outwards, etc. You can do pretty much everything very simply because it's not simulated. So I like this. So, but we're going to do some more things here also. We're going to add a lag to this, which actually will probably make it even a bit more smooth. But what I want to do is I want to overshoot it. So I'm just going to bring down the lag to something like 0.1 maybe, and bring up the overshoot to something more. Or maybe that's exaggerated, but like 0.3. Oh, so we're going to do change to mouse up so I can just dial in the numbers without it starting to cook. Okay, the anti-aliasing kind of causes some flickering here, but I guess that's fine. So that's kind of cool. And we're also going to add a spring. And spring is kind of hard, but I think it works really well on grass. Because it kind of gives it repetitive kind of. Maybe the bend is too little here. I think they're moving a bit too straight. I think they should bend a bit more. So yeah, let's bring up the damping constant here to like 3, so we get a little bit less. That's cool, but what I want to do here is I probably want to go up to the bend again and look at this. Maybe we need to add it to like 120 just to get a more bendy thing. And maybe go down here and also take the curve view thingy and actually sorry, we need to look at the relevant thing. Yeah, we should get something. Why don't I get anything from the curve view ramp here? Here's the mix. We can bring. Nothing happens. Oh, it's a mouse up thing. Okay, auto update now. That's good, I think, still. The normal thing is good. But on the band, I think, okay, down here, if we just look at this, and we have the curve view thing here. So let's see. If we take this up all the way, okay, so this is the problem I have is, should be lower quite earlier, I think. Seems to just give me very straight, non-bent here things. Let me see. So let's just look at this. Could actually just lock it here. So we have this. we have the mix here of the curve view and the position. So if the bias go down to 0, we should have what we had. Once again, nothing is happening. So the second ramp, oh, that's the thing, it should be lower here, I think. I think that's what's fucking it up. Here we go. Something like this, maybe. Most should bend, some should bend less. Maybe like this. Now we have a better bend, I think. And still, maybe, what happens if we exaggerate it? Might be a bit too much, but I still think it's better. Yeah, I think this is better. It was a bit too weak before. So that's cool. So the clumping we keep, the lengthening we do, and then we look at the channel here. I think this looks pretty cool. What we could do is we could, in the end, we could maybe filter it a bit more. We could try to take this down to 2 and see what that gives us. I think this is good. And what this gives us is kind of like a animation-wise, you know, it kind of springs a little bit, which adds a little bit of realism to it, in my opinion. And if we want to remove, maybe get some minor annoying things. So what we could do is we could just do a lost filter as well. I sometimes do that. It's very weak, like 0.2. And we could also probably just take the filter width to half so it doesn't look as many frames around it. But I think this is good. So this is, in my opinion, something that looks good enough for many things. If we want to visualize this a little bit more clearly, what we could do is always to do like a wrangle and just do a color from the curve view. So we can just do at CD equal to ramp, we can call it, and just look at curve view. And of course, this is by default a spline ramp, so we're just going to change this to a color ramp, ramp type color, apply, accept. Then we can just do something that's dark green here and a bit lighter green. Then just add something to the top, like white tips, kind of, just to see what's on top and what's not. So this is not like a shading color thing, but rather maybe it's a bit too saturated. Maybe it should also be a bit more yellowish. I don't know. It doesn't really matter. What we see here is we see what's on the top and what's on the bottom a lot easier, especially if you have like a light background. But now it's kind of hard to tell. I think background I can do black is better, probably. So you get a little bit more clear view on what's going on. So what we could do then is we could save. We could bring the scatter up to something a bit more fun, like maybe 25,000. Oh, fuck me. Here we go. A shop does not like 250,000 points with times 8 over 100 frames. That will be too much for it. So let's see what this gives us. So there we go. It's a bit more dense, but it's still playable in real time. And I mean, we could also change I think it's fine. So we can just do a play blast of this and call it done. So let's see how it looks. guess rewriting over my old play post. I guess that's fine. So here you go. Something like this. I think that looks quite nice, actually. You could, of course, add a lot more to it and do other stuff with it. But for just having something that's animated, maybe not a hero object, it works quite well, actually. And it's also very art directable compared to a sim, I think. So that's it. Thank you for watching.